Okay, good morning everybody and welcome to the CEIA Maths Tutorials Online. This week we have Geometry of the Line and it's going to be delivered by Mark Murphy, who's a chartered engineer and knows a lot about bridges. Over to you, so Mark.
Thanks, Eamon. Good morning everyone. Mark Murphy is my name. As Eamon said, I'm a chartered structural engineer. I'm just going to share my screen now. So this is the first time I've ever done a Zoom presentation, so if there's any glitches, I'm sure you'll bear with me. I just close the poll. So I'm a structural engineer. I set up my own company 10 years and 2 days ago, so just celebrated 10 years in business on Monday. I think it was Monday, 1st October. MM Consult is the name of the company I set up. It's my initials, MM Consult. I principally do bridges, and maybe I'll just go in here and I'll just show you some of the projects that I do. On previous years, when we get feedback from the seminars or from these tutorials, some people say I talk too much about bridges, but most people say I don't talk enough about bridges. So I talk a little bit this morning, and I try and get the balance right. So basically, what we do when we first of all, it's all the work for the county council I do. So the first thing we would do is we would look at inspecting the bridges. So I'll just show you some of the photographs here now. For example, this bridge here is in Carlow. It's a very nice bridge. I don't know if I can zoom in, I can a little bit. So the majority of bridges in Ireland are masonry arch bridges. So we'd go out, we put on our waders, we'd inspect all the different elements of the bridge. We do a report, but then based on that, I mean, it's another nice bridge in Carlow as well. We then deliver our reports to the council and decide whether or not the bridge needs repair work or not, So maybe I'll go back then just to show you some bridges that we have repaired. We'd also carry out calculations on the bridges as well. So this one is in Kilsheal in Tipperary. It's not Lofty Bridge, actually, it's the other one. It's a sister bridge. This goes over the River Suir. So this is a very, very big bridge. The span there is about 63 meters, so it's quite a big structure. So we would have gone out, we would have done an inspection, we would have got a topographical survey of it, we would have put all that information then back into a structural program to analyse, can it take the required loading, which at present is 44 tons of loading across Europe. And in this case, we found that the bridge wasn't, so we had to come up with some strengthening works on that, So I'll just go back here on the page and close that. That's not Lofty. And I'll just show you some of the projects that we've actually completed. So this bridge here, Kelly's Ford Bridge, would have been an old steel bridge that would have been built back in the 20s or the 30s, I think, by two brothers who were in the British Army at the time. And we just found that the bridge had gone too far and it needed repair work. So we replaced it with modern concrete beams and an aluminium parapet. So that's what I do basically, right? And people ask then, do you use maths every day? Sorry, I'll just get it. We're back again. Do you use maths? And I would say every day. And as I go through the coordinate geometry of the line in a minute, I kind of share some stories where I actually do use geometry of the line on a daily basis. Just to show you some other things we do as well. This is in Carlow town. This is a Hanover weir fish pass. So if you can imagine, there's lots of weirs on our rivers in Ireland, and they prevent a barrier to fish passage. Fish can't get over the weir. You see salmon jumping at weirs and what have you, but that's not what fish aren't designed to jump, So we put in these rock ramps to enable the fish. What it is basically is a set of steps, so it's easier for the fish to get up and over the weir, right? That's another one, and the final one that I'll show you. This is an interesting story with this one. I'll show you. This is in Castletown in Mount Rat, which is in County Laois. Now, there was a big problem here with the weir. You can see the weir. I don't know if this works, so no, it doesn't. But the weir there is just going along let's say, horizontal to where you can see the still water in front of that. That's the existing weir. Now that was 2 meters high, and salmon were jumping at it, and only the strong salmon would survive. And like a lot of salmon would be killed because they just get tired, and then they can't go up to their spawning grounds higher up on the river. That's the River Nore. Now we had one problem with this rock ramp. It worked. It's working fantastically well. All the fish are getting up now. There's none dying, but very few dying, and it's a success. We had one problem, however. The local GA club in Mount Rat have a salmon leaping on their crest, and they wrote a big article on Facebook how disappointed they are that there's no longer salmon jumping at the weir. But we tried to tell them that salmon aren't designed. They shouldn't be jumping. They want to swim. So that was the only issue with that. So look, that's who I am anyway. That's that's what I do. As you can see, just even from looking at those pictures, there's a lot of geometry involved. I do use geometry every day, and I do use the formula that I'm going to present to you today as well, right? So look, maybe we'll just kick off with geometry tonight. So first of all, we go to the curriculum, right? I broke it down. There's only actually 7 things you need to know. And I go through each of those topics as well. There's the slope of the line. I think this works now. There's the equation. There's something else I can use. Doesn't matter. Equation of the line, area of the triangle, perpendicular distance formula, the angle between 2 lines formula, the divisor's formula, and the distance formula. Only 7 things. Now, I know a lot of you like doing past exam questions and keep doing them and regurgitating them, and then you think, right, I know everything. I'm going into the exam. I've covered all the past 10 years. Because, let's be honest, coordinate geometry of the line is one of the easier topics, right? I really feel that if you really know the background theory and really understand each of those 7 topics, that, when you go into the exam, you can answer any question. That's what I do every year. Like say, for example, 2 nights ago there, I just put out 2019 paper. Now I don't do maths every day, like, your curriculum. And I could do it because I understood. I mean, I've been teaching this now for the last, 7 or 8 years with CEIA and previously with Engineers Ireland. But I really feel if you understand the theory and the background and really understand coordinate geometry, any question will be easy in the exam for you. Because it's a kind of an easier topic, they tend to throw out some let's say left of field kind of questions in the exams, maybe that weren't there before. But if you really understand the theory and the background knowledge of coordinate geometry of the line, you'll be able to answer it. And particularly last year, I think 2019, 2 years ago now, wasn't it? 2019, the paper was, you really need to understand geometry of the line. So look, we'll go through each of those topics anyway today, and I'm aware that I think it was 75% have done this already, right? So I might be going too slow for some of you, but for others, I might be going too fast. So look, I'm going to try and get the balance right. But certainly at the start, it's going to be very basic. But I just want, maybe you just take 1 or 2 nuggets from it and really understand coordinate geometry of the line. So look, we'll kick off there now with the actual the basics, right? So the first, I'm writing on the screen, so it's a little bit difficult, but look, hopefully it'll work out. So the first thing I'm going to do here is I'm going to call it basics. Okay, so I just draw maybe just an X and Y. And I put on the point A. So I call that A. Call it AB, right? Okay. Now, what does that mean, right? Now, I'm not a maths teacher. I'm an engineer, right? And I hate like a lot of this wordy stuff. So I won't be doing too much of this, right? What is it? What is coordinate geometry line? Basically, this point AB, right, is defined as the position AB. It's defined as the intersection of the vertical line through A. What does that mean? I'll show you. It's just a dotted line down here, right? That's A. What does that mean? That means that length there, right, is A. That's all that means, right? So in other words, you're coming along A units along the x-axis. For example, that could be 5, it could be 4, whatever, right? And then it says, so again, the theory is position AB is defined as the intersection of a vertical line through A on the x-axis, which is this, and a horizontal line through B on the y-axis. So look, we just draw a line here, and that's B. And that just means that height there is B. Okay? That's all that means. That's coordinate geometry line. That's AB. That's the definition. I think when we were in Scouts, we said along the, along the corridor and up the stairs, right? AB. So just going back to it there, right? I'll give you a little bit of history on it. It was a guy called Descartes. He came up with the idea that lines can represent equations in a book called Geometry. He invented the Cartesian coordinate system. It was the very first time that algebra and geometry were forged together. It was a revolutionary at the time, right? No one had ever done it before. And he made both easier to understand. He made geometry easy to understand, and he made algebra easier to understand. He wasn't a fan of overexertion, however, and he certainly wasn't an early riser. And in 1649, he moved to Sweden to be the personal tutor to Queen Christina, who was an early bird and woke daily at 5 a.m. Soon after he arrived in Sweden, he contracted pneumonia and he died. So that's the background or a bit of history on coordinate geometry of the line, okay? So what I'll do now next is let's do a little bit more on basics. And again, I know it is basic, but I think it's no harm just to get it out of the way early, okay? So again, I draw y-axis and the x-axis. Let's just pick a line. So let's say this is the line y equals x. I have to get this right. It's not too bad. So I call that y equals x. And I draw another line. Let's call this, I'll try and draw it correctly now if we can. It's like this. And that's the line you'd say y equals 3x minus 2. Okay, so when you draw a line, so what you're saying is for any equation in x and y, the points where x, y has values for x and y that satisfy the equation, describe a line on the graph. Again, I hate all these words. I'll be doing no more today, that's the end of it, right? So if we just look at this line here, y equals x, okay? So you know that that's the 45-degree line that goes through the origin, right? So for example, 0, 0 is on that line, 1, 1 is on that line, and 553 is on that line, right? So that rubbish that I just described there, that basically, that's all that's saying, okay? So if we write down these two lines, okay, they intersect here, okay? Now, I just write them down, let's change the pen color. So we say A here, right? I'll call this is line A, let's say, right? So this line is A, we'd say. And this line is B. So A we can write down as y equals x. And B we write down as y equals 3x minus 2. Now, usually in algebra you'd solve that by simultaneous equations, and that's actually what we're going to do here, okay? So we'll just see it visually then on the thing, right? Now, another thing I'll do again in a minute is setting up lines on, actually maybe I'll do it now. So for example, I'll do it back over here, okay? So if you're given the line y equals 3x minus 2 and you're asked to draw it on graph paper, what I always do is look, I put in when x equals 0, let's look at this line. When x equals 0, y is equal to 3 times 0 minus 2, okay? So y is equal to 3 minus 2 is equal to 1. So we know that the point 0, 1 is on that line, right? Is that right? So when x is equal to 0, so when x is, sorry, that's wrong, isn't it? Let's double check that again. When x is equal to 0, y is equal to minus 2, that should be, shouldn't it? So it's 0 minus 2. Okay. So I'll just extend this line down here if I can. Okay, so that point there, right, we know that the coordinate 0 minus 2 is on the line B. Similarly, we can write when y is equal to 0, so that 0 is equal to 3x minus 2. So we can say that, therefore, x is equal to, what, let me see, is a half, is it? And y is equal to 0, does that make sense? Y is equal to 0. X is equal to, no, hold on, we'll write just 3x is equal to 2. So x is equal to 2 over 3. I think that's right. I'll just double check that. Y is equal to 0, 3x, bring that across, 3x is equal to 2, x is equal to 2 over 3. So we can say that point here is over 2 over 3, yeah? 0. I think that's right. Even if anyone else is telling me otherwise, you might let me know. So that's how you draw. Then you have your 2 points. You have this point and you have this point, and you can draw a straight line through it. Now, so we have drawn line B, y equals x. That was easy to draw. So we just solve this then, right? And then we'd say that when y is equal to x, so we just plug that into this equation. So that becomes x is equal to 3x minus 2, and then we can say from that minus 2x is equal to minus 2, therefore x is equal to 1. And when x is equal to 1, y is obviously equal to 1. So the solution to that is 1, 1, which looks about right here. You know, that's up about 1 there, isn't it? And that's roughly 1 there. So yeah, we drew it pretty accurately. So the solution to that is 1, 1. Now, that's pretty much the basics. Now, there's one other little thing, because I know when I was doing leaving certs a long time ago, one thing that really always confused me was XY and X1, Y1 and X2, Y2. I just want to make one thing very clear here, right? X, Y, that's unknown. So when you see X, Y, we don't know the values, right? So unknown. When you see X1, Y1, or X2, Y2, or anything else, right? X20, they're known values, okay? And for the rest of the morning now when I go through all this, keep that in mind. That's really important. So if you have X, Y, it's unknown. It could be anything, right? That's what we're trying to find out. But when you see X1, Y1, and X2, Y2, and all these formulas, like for example, the slope of the line, which I'll go to the next, they're known values, okay? That's the last thing I'm going to say on basics. So I'm on to a new page.
Mark, I wonder, sorry to disturb you there. I've got a question from the audience about where did you get the numbers from? And we're wondering, was it from a past paper or what? So I wonder if you could just clarify that, please.
Which numbers are they now, Eamon?
I suppose the numbers you were using in the example a minute ago.
Purely made up myself. That was just to show the basics. There's no, I made them up myself and just picked the line 3x equals or y equals x minus 2 and y equals x, just to show people the basics and to show that coordinate geometry line, whilst you are always doing algebra and doing simultaneous equations, I just wanted to show graphically that that's the solution graphically. You know, y equals x is a line and y equals 3x minus 2 is a line. And actually what simultaneous equations is doing is solving where they actually intersect, where those two lines intersect. Now, the only case where you won't get two lines intersecting is if they're parallel, but we'll talk about that later. I hope that's what we're looking for, Eamon.
It was the number 553.
Oh, totally random, 553. And what I was showing there was that I was looking at this line, line A, right? And I was just writing out a list of numbers that are on that line. For example, 0, 0 is on the line. That's 0, 0 there, right? Just highlighted in black. 1, 1 is on the line. 2, 2 is on the line. And then I was just giving a random number that 553, the coordinate 553 on the x and 553 the y is also on the line. That's all I was showing there. For example, 1 million, whatever, right? The coordinate 1 million, 1 million is also on that line. In other words, what it's saying, like it's very basic, it's just saying y equals x. So y coordinate equals the x coordinate. So what the equation is y equals x, it's also telling you that the x coordinate equals the y coordinate for all cases on that line. Is that okay, Eamon?
I think that's brilliant. Thanks, Mark.
All right. Okay, so the next topic, or the first topic I'm going to cover is the slope of a line. So I write down here, slope of a line. Okay, so again, I'll just draw a graph. I suppose, no, I'll give the definition here of the slope of a line, right? I won't write it down. But there's lots of, I mean, we all know what the slope is. We know if it's a steep slope, if a hill is a steep hill, then it has a high, let's say, slope. And if it's flat or more or less flat, then it has a low slope. But the definition here I got from some textbook is the gradient or slope of a straight line measures its slope or its steepness in relation to the x-axis. That's the important thing. It's in relation to the x-axis. So if it's on the x-axis, it's 0, and it's going to get steeper and steeper and steeper and steeper, right? It increases until we get to infinity. So again, the gradient or slope of a straight line measures its slope or its steepness in relation to the x-axis, i.e. the amount that y increases for every unit of x. Okay? So I'll just draw the y-axis, the x-axis, and I just draw any line. So we'll say that the angle that line makes with the x-axis is theta. Sorry, now there's something funny goes on with the pen here when I draw a circle, so I just undo that. So that's theta there, okay? Nice draw. That's the angle that makes with the x-axis. So we just pick 2 points on that line just for our definition, right? So we say that that's the point A here. That's A, and we just call that x1, y1. So again, now remember when I have x1, y1, that's a known number, okay? And I pick a point here, B, and we'll call that x2, y2. Okay, change color. Now, the slope of a line, right? We must define it, okay? So what I do is I'll create a triangle, okay? And what actually I'll do, remember at the very start I did the dotted lines down to the axis, so I'll just extend this a bit here. Yeah, that works, okay. Okay, so I bring that down here, and that's the point x1. So again, looking at look, that's x1, right? So that's the distance from 0 here. That's actually x1, right? So just to, I know this is very basic for some people, but for some people it's just like, oh, that's actually what it means. It's the distance x1 from 0. So that's 0, 0, okay? Just to write that down. That's the 0, 0 ordinate. Okay, so that's A, right? x1. And then we look at B. We bring a dotted line down from here, and we have x2. We do something similar with the y-axis. So that's y1. And again, a little bit of space. But that's y1 there, okay? Right. Now, what I'll do here is, so we're trying to get the slope of the line, right? Which is what? It's the amount of y increases for every unit of x. So let's just complete the triangle here, okay? Now looking at the triangle, I'll just call this P and Q. It can be anything you want, right? So we're trying to see how much P increases for every unit of x. Okay, again, that's all theory, but look, let's go through it and it'll make it easier, okay? So we define, from our wordy definition that we had, we say that the slope, and it's always called n, isn't it? Slope, well, that's just equal to P divided by Q, isn't it? That's from the definition, i.e. the amount of y increases for every unit of x, so y divided by x. So let's look at y. What's that distance? That's all it's asking us. So what's that distance there, right? That's P. So we can say that P is equal to, well, it's that height. So it's the height from here to here minus the height from here to here. So that's P equals x2 minus x1. Similarly, what's Q? Well, that's that distance Q there, right? So we say that Q is equal to, sorry, P is not equal to that. Hold on, I'll rub that out. See, in the class now, fellas, be roaring at me and telling me I did it wrong, but that's okay. It's actually y2 minus y1, because it's this height, which is y2 to here, minus the height to here, which is y1. So P is equal to y2 minus y1. Similarly, Q is equal to x2 minus x1. Okay, so we have P and Q. So now we can just substitute those in for P and Q up here. So that's equal to y2 minus y1 all over x2 minus x1. That's our first formula. That's the first thing we need to know, right? So I'll put that in the box so we can just say, we just define that m is equal to y2 minus y1 all over x2 minus x1. I'm trying to put these in red boxes so that we know. Okay, that's the first thing we need to know, right? That's the slope of the line. I think that's pretty basic. I think that would have been covered in junior cert, right? But let's look at the next thing now. I go on to the next page, right? So I'm not an expert on trigonometry. In fact, it was my least favorite subject, right? But I want to show you something here. So I'll just draw a circle, I think, right? And this is the unit circle, okay? So we draw the x and y coordinates again. That's not too bad. I don't do that. I'll try and do it a bit better. Okay, that's a bit better, slightly better. Okay, so the unit circle, right? What does that unit circle mean? It means that it has a radius of 1, okay? Now, going back here, look to the line theta, we had that, so if we just put that in again. So we're looking at something where basically what I'm going to do here is I'm going to make trigonometry and coordinate geometry together, okay? So you all remember what's the definition of, let's say, cosine of theta, right? So the cosine of theta is equal to, sorry, I'm going to confuse myself now if I do it that way. Cosine of theta is equal to the adjacent over the hypotenuse, isn't it? Cosine of theta is adjacent, so that's that line there, P. We say that P, right? So it's P over 1, isn't it? Yeah, so then P is equal to the cosine of theta, right? And similarly, the Q there is equal to sine of theta, okay? Now, so in other words, I just rub that out and write in what actually it is. So that's equal to the cosine of theta, that length, and this height here is equal to the sine of theta. Now, we all know, so we write down then what we have. Previously, it's the height, so it's the P divided by the Q, right? So again, it's the P, which is sine theta, so I write down sine of theta divided by the cosine of theta. Okay, but we know that sine theta divided by cosine theta is equal to tan theta. So we can say that m is equal to tan theta. All right, that's just a definition. In other words, we now know the slope in trigonometry. Or similarly, you can just bring it another way. You can say that theta is equal to the inverse tan of m. Let's put a box around that. Again, because the coordinate geometry is quite a simple subject, they might throw something like that in like, you know, sometimes they mix up coordinate geometry of the circle with coordinate geometry of the line. So there's no reason why they wouldn't be able to mix up some trigonometry with that as well, okay? So that's another thing to know. So that's the unit circle, we call that. Okay, one more little thing on the slope of a line. I'll draw my axes again. That's X, that's Y. Just change color. And if I draw a line here, okay, and pick a point on it, let's say P, call it P, and it has the coordinates of A, B. So that basically what that is saying is that this distance here, that's A, so I should draw that differently. So we just say that's A here, and this is point B. Okay, now if I drew a line perpendicular to that, so I just change it to purple. So I'll draw a line perpendicular to this, like that. That's not exactly perpendicular, we'll try it better. Let's say it like this. It's a little bit better. Let's call this point, we call that P, we'll call this one, so I shouldn't have done, yeah. We call this Q. And now just from basically looking at that, we know that that's A there as well, right? Isn't it? And this distance here is B. Okay, so that's that height there is B as well, right? And so this is actually the coordinate minus B. Now, let's look at the slope of P first of all. So we write down m of P, right? So we know we have this coordinate. We also have the coordinate here, 0, 0. Let's write that down, okay? So MP, the slope of B is y2, we write that down again, y2 minus y1 all over x2 minus x1. So the slope of P in our case, y2 is equal to B. So we write down B, and the x1 is equal to 0. So minus 0 all over A minus 0. So we say that the slope of MP is B over A. Now similarly, we look at the line Q, which is this line, sorry, it's Q. And we'll do the same again. So we say the m of Q is equal to, so in this case, our y2 is actually this coordinate up here. I should write that down, actually, that's minus B A. No, yeah, that's okay, I think, right? So we're going over minus B and we're going up the height A. So the A is the same because we're just basically rotating it. Okay, so let's look at that. So the m of Q then is equal to y2, which in this case is 0 minus A. And then we look all over the x's. So that's 0 minus B. Okay, so that works out as minus A over B. Okay, now we can look at the two. We have B over A in one case and we have A over B, but with a minus sign, right? So what we can now say, we can say for perpendicular lines, we can say that m of P multiplied by the m of Q is equal to B over A multiplied by minus A over B, and that's equal to minus 1. So in other words, what we can say is that if we have, it comes up in the question, up in the exam quite a lot, you know, you have a line, find a perpendicular line. Well, if you find the slope of one line, you know that the perpendicular slope is that slope multiplied by minus 1. Okay, so that's important. And similarly, we'll do it again later, so you don't need to think about it too much now. So similarly, for parallel lines, right? The slopes are obviously equal, so we say that MP is equal to MQ. So that I write down the box again. So for perpendicular lines, MP multiplied by MQ is equal to minus 1. And for parallel lines, MP is equal to MQ. Okay. Now we'll do the MP by MQ minus 1. We'll do it in trigonometry as well later, and it's in section 5. It's the angle between two lines formula, but we'll come to that as well. Okay. So now we'll go on to the equation of a line. This is the second topic. Okay, just add a page. Trying around to add pages. Okay. Right, so the second topic is equation of a line. Okay. So again, we start off with this case with the what we had earlier. It's the slope, right? Is y2 minus y1 all over x2 minus x1. Now, this is where I talked earlier about unknowns and knowns, right? In this case, let x2, y2 be an unknown, right? It's just to get the equation in a more general format. So I'll just write down here, let x2 and y2 be unknown. So in other words, instead of writing down x2, y2, I'm going to write down x and y, right? So in this case, let's substitute in x and y so that that'll go to xy, we'll say, okay? So in this case, we say m is equal to y2, which we've substituted as y, minus y1 all over x minus x1. That's an important small little leap I did there, right? I could never figure that out. How did you get from y2 minus y1 equals divided by x2 minus x1? Where did they get from that to y minus y1? That's what they did. They just substituted in, you know, they just said, let's let the known values of x2 and y2 be unknown to write a more general formula for this equation. So rewriting that, right, we get, let's write down rewriting. We get y minus y1 is equal to m into x minus x1. Now that's a formula or a format that you're probably familiar with. Okay. Okay, that's that one, okay? Now, let's continue on with that, right? Let's look at this again. So we have y minus y. Let's put them all across. Now, this isn't in the textbooks. This is just something I did myself, but it makes it kind of clear, okay? What if we just put the y1 across the other side? So that becomes y is equal to mx, right? Minus mx1 plus y1, isn't it? Yeah. Now, let's look at this again. So we have y equals mx. Let's say I'll write it another way. Plus y1 minus mx1. Now, in this case here, right, y1 is a number. It's a known value. M is a known value. It's a slope. And x1 is a known value, right? So what we can just say is that, look, that's all a number. That could be, say, 4 minus 3 times 2, right? We'll just call that c, because c is a number as well, okay? So then we can rewrite that, and that becomes y is equal to mx plus c. Now that's another format that you're familiar with, isn't it? So now we've wrote the equation of the line in two different formats. Let's call that 1, let's call that 2. Okay? Right, moving on there, okay. So I'll just do one other thing, right? So I go on to the next page, I think it's 2 fingers, right? This is tricky, right? It's working now, good. So we have the equation line in two different formats. There's a third one. But before I do that, let's just draw the x-axis. The x-axis and y-axis. That's y, that's x. Let's pick a different color, blue, and let's draw a line. And let's call that, you know, the first format, which is y is equal to mx plus c. Now, you notice that it crosses the y-axis at a point and it crosses the x-axis at a point, okay? So remember at the very start when basics I said, so let's say at y equals 0, so y equals 0, that's the x-axis. So at y equals 0, let's plug that into the formula, that 0 is equal to mx plus c. Therefore you can say x is equal to minus c over m. What does that mean? That means that the coordinate of this point here, when y equals 0, is minus c over m 0, okay? I think they call that the intercept, so that's the x-intercept or whatever, it doesn't matter. So let's do it, let's find this point. So at that point, let's say 0, 0. At this point, x is equal to 0, so at x equals 0, y is equal to c. That's easy, right? So in other words, that point there is c. So the coordinates to this are over 0, so it's 0, c. In other words, that height is c, right? That's all that means. And that distance there, sorry, is that distance there is minus c over m. Let's see. Okay, that's called the slope-intercept equation, right? Sorry, this y equals mx plus c is called the slope-intercept equation. And that's what it means. And that came up a few years ago. And they gave you an equation and said, where does it cross the x-axis? Well, if you're really clever, you could have said, you know, at y equals 0, x is minus c over m. So that brings me on to, I'll write it down here in a new box. This is called, the final part is the general equation of a line. And this is the format you're all familiar with as well. And that's just ax plus by plus c equals 0. So I'll just give that a red box again. So that's number 3. So now we've written the equation of a line in 3 different formats. They're all the same, just different ways of writing it, okay? Now, one thing about this comes up as well, right? So maybe I'll write out all 3 again. So we had, that's one of them. We had y is equal to mx plus c, didn't we? And what was the other one? Y minus y1 equals m into x minus x1. That's the 3 of them, okay? No, they're all exactly the same. So you can manipulate them. So let's go on to the next page and just do one small more thing. Again, you don't need to know these, but it's quite useful and it's kind of interesting to look at it. So let's look at ax. Let's change the pen color. Ax plus by plus c equals 0. Now let's put in the slope intercept formula into that, right? So that's what we'll write out again. Look, that's y is equal to mx plus c. So let's rewrite this. Let's look at this one. So that becomes y. So I'll write it out slowly. By, all I'm doing is putting everything over to, I'm keeping the y's on the left hand side and everything else on the right hand side. So that becomes by minus ax minus c. So that's the same thing, right? So rewriting that again, let's say y is equal to minus a over b, x minus c over b. Now let's just look at this, right? And look at this. So m there, right, and the ab there, okay? Basically what you're saying there is, if you see this formula, for example, then you can just say straight away that the slope of that line is equal to minus a over b. For example, let's write down 7x plus 3y minus 4 equals 0. Looking at that equation, you say, how in God's name will I get the slope of that? Well, it's very easy. It's just m is equal to a. What's the a value here? 7 over 3. And don't forget the minus. Okay? That's the equation of the line and the slope of the line. And they're completely, as you can see, intertwined. Now, the next few are basically formulas, so I'll go through them fairly quickly. So what time is it now? It's 11:15. I plan on going until 11 o'clock. We get 3, 4, and 5, and maybe even part 6 done. And we'll only have 2 little parts then after the coffee break. And then after that, I'll do some past papers. So we'll continue on. So graph paper, line grid. So number 3 is area of a triangle. Okay. We have the y and the x-axis again. And this, quite simply, is if you have a triangle, well, I'm going to do that a bit better. That's really bad. We'll try again. Okay, that's not too bad. So we have a triangle like that, and we have some coordinates. Let's just go through.
Sorry to interrupt.
Yeah.
Sorry, Mark. Sorry to interrupt there. I've got a question in here from the audience. One is just saying, could we just see the equation from the last page?
Yeah.
And also there was a question came in from one of the earlier slides there. It said the question, is it y1 plus m is a constant, i.e. c? No, I'm not sure exactly what that question
I know what that means. I go back to that. So I'll just leave that up there for a second so they can see the equation. I think that's okay. And I'll go back to that then. Yeah, it's not in the textbooks, but what I was trying to do there is just link equation 1 with equation 2, right? Just to show them that they're the same. So I developed, let's say, the line or the slope intercept equation from this. So what I did is I just took that equation, which is y minus y1 equal to m into x minus, there's actually a bracket missing there. So, and then I just multiplied it out, so it became y is equal to mx minus mx1, which is m times mx1, right? Plus y1, and then that's just the y coming across over there. So that's just rewriting that line. And then the next line is y is mx plus, I just bracketed I brought the y1 over and minus mx1. So just to kind of make it a bit more organized. But then what you looked at here is that y1, well, that's just a number. Remember, I said earlier it's a known number. And the slope, well, the slope is always a number as well. It could be like, you know, a slope of 1, slope of 2, you know, 3, whatever. So that's a number. And x1, similarly to y1, is also a known number. So what I'm saying is, like, for example, if that was like y1 was 10, slope was 2, and x1 was 3, that would be 10 minus, or 2 times 3 is 6, that's 4. So that's basically just a number as well. So instead of writing out y1 minus mx1, I just call it c, and c is a number. So in other words, then that becomes y equals mx plus c. Okay, Eamon?
Yeah, that's great. Thanks, Mark.
Okay. Okay, right. So the area of a triangle, right? Let's say we has the coordinates. Let's call this x1, y1. This is x2, y2, and this is the coordinate x3, y3. Now, the area of a triangle, I don't have to go through the theory behind it, but the area of a triangle is defined as is equal to 1/2 times x1, y2 minus x2, y1. Just going to double check that to make sure it's right. Yes. Okay. So I'll put it in the red box. Okay. We go back to our model here, our graph. You can see there's something wrong because we have 3 coordinates. We have x1, y1, x2, y2, x3, y3, and that doesn't work in our formula, okay? So we do something called translation. So what we actually effectively do is we take one of the points. So in this case, I take this point and we transfer it to the coordinate 0, 0. So to finish off this equation, you should actually say the area of a triangle is that when the vertices are 0, 0, x1, y1, and x2, y2. So we have to take one of the coordinates. It could be, we could take any of them. We could take x1, y1, it doesn't matter, right? And we translate. So in translation, what you do is, what you do to one coordinate, you must do to the other. So that distance and the same angle, I must move all of them the same way. So I'll attempt to draw that. So that's something like that, isn't it? And this one probably goes somewhere like here. So then I'll redraw that triangle. I'll do it in a different color. Maybe something like that, and something like, oh, this isn't exact, but you get the gist. Okay, so that's just a translation. So I just cut that triangle here and I moved it down to with one of the vertices on the origin, 0, 0, okay? So then we have new x1, y1s. I think some places they're called, like, you know, when you do translate, this becomes x2, y2 with a dash over the top and y2 dash like that, right? Doesn't matter in this case. So that's what you do, it's called a translation. And the best way to show this actually is by doing an example, okay? Because let's say we had, let's say, I'll call this, let me see there. So we just call this A, B, and C, okay? Doesn't matter, it's not accurate, but that's not important. So we say that A is equal to the coordinate 3 minus 1. It's not, right? I haven't drawn it right, but it's just, it doesn't matter. It's the principle, right? So let's say the coordinate of B is equal to 4, 2, and the coordinate of C is equal to minus 1. Sorry, yeah. Minus 1, 3. Okay, so they're the three coordinates, right? And then we look at our formula and we see that we need one of the vertices to be 0, 0. So we need to do a translation here, okay? And the way to do a translation is, there's lots of ways of doing it really, right? But so let's say we pick the first point A and we're going to make that 0, 0. So this is the key to the whole thing about doing area of a triangle questions. What are we doing to 3 minus 1 to make it 0, 0? Well, we're subtracting minus 3 from the x coordinate and we're adding 1, aren't we? To get it 0, 0. So in other words, 3 minus 3 is 0, minus 1 plus 1 is 0. Now, what I said earlier, what we do to 1, we must do to all exactly the same. So let's transform all of them. I'll just do it different color. So that's goes here. So 4 minus 3 becomes 1. And 2 plus 1, 2 plus 1 is 3. So now we've transformed the b coordinate to a new b coordinate, right? So in other words, we just moved the triangle. And we do the same for the last one. So minus 1 minus 3 becomes minus 4. And 3 plus 1, well, that becomes 4. So now we have them in the format that we want, right? We have 0, we have x1, y1, and we have an x2, y2, okay? Then we just plug that into our formula, and we say that the area is equal to a half times x1, in this case is 1. It doesn't matter which way you do them, actually. You should get the same answer. So it's 1 times 4 minus 4. Oh, I did it a different way, it doesn't matter. 3. I could have done them in brackets too. All right, so let's work that out. Is equal to a half into 4 minus 4 minus 3 minus 3 becomes plus 12, doesn't it? Am I right? Yeah, plus 12. That's half of 16, so that's equal to 8 units. Okay, that's the area of the triangle complete. We've got any questions on that there, Eamon, or we're okay to move on? I think it's pretty straightforward.
No questions at the moment, Mark.
Okay, we'll go back anyway if we need to. The next one we do is a perpendicular distance formula. Okay, so again, let's draw. We have the y coordinate, sorry, y-axis, the x-axis, and we draw a line. And let's pick any point, we call it P. We call it P x1, y1, a known value, right? And we'll just call this line here, look, we'll call this line L. Is AX, I'll call it, use the general form. AX plus BY plus C equals 0. So the distance formula basically means, we want this distance is the perpendicular distance, right? It's not just the shortest distance, isn't it? Because if you went that way, that's going to be longer, isn't it? You know, the perpendicular distance is always the shortest. So I always think about a ship at sea and it wants to go to the coast, right? It's going to go straight at it. It's not going to go in an angle. We won't get into currents and all that. So what we're looking for here is W, that distance. That's all. That's what we've been asked for. The perpendicular distance formula, okay? Yeah. So I'll just give you the formula. The formula is for W, that distance is equal to A times x1 plus B times y1 plus C all over square root of A squared plus B squared. Let's put a box around that. Right, that's the distance formula. Let's look what actually all we do. It's very, very simple formula. You get your two coordinates, which are known values, could be 3, 4, 7, 8, whatever, and you just simply put those values. So this x1 goes in here, and this y1 goes in here. So A, B, and C are numbers. No, you substituted the unknowns, which were x and y, with known values, x1, y1. So it's A times x1 plus B times y1 plus C, all numbers, divided by A squared and B squared, which are numbers. So you get a number value. Okay, again, that'll become clear when we do some examples with that later. What time is it now? We do one more, I think. So we got to the next page, and it's number 5, and that's the angle between two lines formula. Between a lot of ways, this is the trickiest one, right? Because it involves a bit of trigonometry. Okay, but we'll just go through it again. So you do your y-axis, do your x-axis. Let's draw two lines because it's the angle between two lines formula. So we draw one line here, and let's define that as L2. It's just the way I've written it, right? And this is the angle beta. And let's draw another line. So that, let's say that has the slope of M2, okay? And let's draw another line. Let's draw it like that. And we call that line 1 or L1. And this makes the angle of alpha with the x-axis. That's beta with the x-axis, right? And that's, let's say, has a slope, or yeah, slope of M1, okay? Now, what we're looking for is the angle here, right? We call it theta. And that's the angle between the two lines. Now, if that's theta, this is 180 minus theta, this angle here, right? We'll just say that's 180 minus theta. Okay, so we just made a few definitions here, right? This is the only one I'm actually going to do, like, first principles theory on this, right? So M1 we say is equal to the tan of alpha. Do you remember at the very start we did that? We said that tan theta, M is equal to tan of theta. So we're going to do the same here. So we're going to say that the slope of M1 is equal to the tan that the angle it makes for the x-axis, right? We said that earlier. And we'll say that M2 is equal to tan of beta. Now, this is where trigonometry comes in. I'm sure you all know this. I'm not brilliant at it. I hate it. But looking at trigonometry, we know that alpha, this angle here, is equal to theta plus beta. I think it's got to do with the, what is it, the two internal angles of a triangle and the opposite angle outside. There's some theory, but that's just a definition, right? So then we can rewrite that. We can say that theta is equal to alpha minus beta. So we can say that just by putting tan on both sides, we can say that the tan of theta is equal to the tan of alpha minus beta. I just took this formula and I put, I got the tan at both sides. Now, from your logbooks, so I'd say here, from logbooks, there's a definition, you don't even need to remember it. The tan of theta, actually I'll keep writing here, tan of theta is equal to the tan of alpha minus the tan of beta. But I should say that's from the logbooks, right? The definition of tan alpha minus tan beta is equal to this, all over 1 plus tan of alpha, tan of beta. I'm not going to go into much into trigonometry, just take it for granted. It's just a definition. And at the start, all I was doing is just manipulating the information that we had. So now, at the very start here, look, we have tan alpha, tan beta, and up here we define tan alpha as M1 and tan beta as M2. So let's fill them in, okay? So if you don't mind, I'll rewrite that over here. So that becomes the tan of theta is equal to M1 minus M2 all over 1 plus M1, M2. Okay, so rewriting that, we can say that the angle, that's what we're looking for, is the tan inverse of M1 minus M2 all over 1 plus M1, M2. Let's put a box around that. Okay, that's the angle between two lines formula, and that's how you derive it. I don't know if you need to derive it or need to know the proof, right, for the exams, but I haven't seen it, but it's no harm just to see where it comes from anyway, okay? Now, let's go back to one or two things here, right? Maybe I can fill in this box here. So, do you remember when we said the parallel lines and the perpendicular lines? This is the last thing I did before coffee, tea, water break, whatever. If two lines are parallel, so if L1 and L2 were parallel, right? What does that mean? That means that the angle between them is 0, isn't it? So like this would squeeze up, if you know what I mean. We could take the angle, if they were parallel, that angle would be 0. No, it's at an angle here, it squeezes to 0, okay? So we'd say then that, therefore, theta equals 0. Now, if theta equals 0, if theta equals 0, so in other words, then that you're saying that this value, this tan blah blah m1 minus m2 over tan 1 plus m1 m2 equals 0. So if we look at that, for that to be equal to 0, the tan of theta equals 0, right? That's from the logbooks as well. For the tan of theta, sorry, that's wrong. Hold on, I'm going to do that. Because the tan of 0 is, yeah. So what we do here is we look above the line because we need this to be 0. So then we can say that m1 minus m2 needs to be equal to 0. Therefore, m1 equals m2. Now, similarly, below, if L1 is perpendicular to L2, right? In this case, theta is equal to 90 degrees. That's obvious, isn't it? They're perpendicular. Now, for that to be right, this is a bit of trigonometry, but just take my word for it. That for the inverse tan of something to be 90, then it's undefined, isn't it? It comes up as undefined or something in the log tables, right? So for that to be undefined, what's underneath the line needs to be 0. So in other words, you can't divide anything by 0, okay? So in that case, we say that 1 plus m1, m2 is equal to 0. So we can say that m1 multiplied by m2 is equal to minus 1. And they're the same definitions that we had earlier, do you remember? Just we did it in a different way. Now, I know I might get some questions on the trigonometry about this, going from this to this, right? It's to do with trigonometry. So looking at this, the theta equals tan inverse m1 minus m2 over 1 plus m2. To get that equal to 0, what's above the line must be equal to 0. So that's m1 minus m2 equals 0, then m1 equals m2. And for the second one, for this to be valid, what's below the line must be equal to 0. So that's 1 plus m1 m2 equals 0. And then that's how you end up with those two values. Eamon, I suggest that's where we take a break. I have the divisors formula and the distance formula to do after the break, and then I have a few extras just to give the guys there just some maybe tips for the exam. And then after that, I suggest doing maybe the last 3 or 4 years papers, and if that's okay with you.
Yes, I think that's perfect. So it's now 4 minutes past 11. Should we say quarter past 11 to restart?
That's fine.
Okay. So see you back here at quarter past 11 for the second part of the tutorial. Okay, bye for now. Okay, hello everybody and welcome back to the second part of today's tutorial, Geometry of the Line. Okay, so I'm going to hand it back to you, Mark, to take from here.
Thanks, Eamon. Okay, so the last two sections, right? 6 is the divisors formula. So I guess again, there's a little bit. I'll show the x and y coordinate, or x and y graph axis. It's the x-axis, we'll say, a bit longer. It's x, that's y. So what we're asked to do here really is just draw a line first of all. It's just dividing the line up, and we're asking for the coordinates of that line or decide the point. So let's just draw a line A. We'll call this point A, and we'll call it x1, y1. And let's say that the coordinate at the end of the line is B, and it's x2, y2. Now, what this is here, like say we just pick a point here on this, and we call it C. We're asked for the coordinates at that point, and we do the general format first of all. I'll just move this here, the housekeeping. Okay, so, and we're asked to divide it in some ratio. So in this case, we'll just say R and S, right? Let me just do it like this. What are R and S? That could be like, say, for example, you have a line there, right, between A and B, and you want to divide it up into 2:1. So R could be 2 and S could be 1. Similarly, it could be, say, if the length of the beam was 10 meters, right? R could be 8 and S could be 2. Okay, and that's all that is. So the formula is quite simple, but there's a little trick in it, and I'll show you now in a minute what that is. So let's do it in blue writing maybe. So the coordinates of C that's equal to the following. It's S times x1 plus R times x2 all over S plus R. And similarly, the y coordinate is SY1 plus RY2 all over S plus R. Okay, so C is known as the internal divisor, right? Now, there's a particular case in this, right? And it's if S is equal to R, in other words, they're similar. So you want to find, it's known as the midpoint, right? So the midpoint then, midpoint, so that's I dot E dot, when S is equal to R, well, that becomes, if you can imagine, if I filled in S for everywhere there's R, will we do it? Yeah, okay. So in other words, S is equal to R. So wherever I see S, I'm going to fill in R. Let's see what happens. So that becomes R times x1 plus R times x2 all over R plus R. You can see what's going to happen here. And then it's ry1 plus ry2 all over R plus R. So we're going to end up here with 2R underneath the line. So if I divide everything by R, well, that becomes 1 plus 1 underneath the line. So that just becomes x1 plus x2 all over 2. And that becomes y1 plus y2 over 2. So in other words, if you have the known points here, x1, y1, say it could be 2, 4, and this could be like, say, 10, 12, whatever up here, right? So by just using this formula, if S is equal to R, in other words, that if C is in the midpoint, so if C is here, right? So just, let's call it D. So D is equal to that, right? That's the midpoint. Okay, and then again, in this case, right, the x1 and y1 and x2 and y2 are known values. Okay, So that's the divisor's formula. Now, you'll see something there, right? You'll see that the S value, I'm actually writing on the wrong screen. So if this S value here, right, well, that actually, if you look at the formula, that's relating to the X1 here, right? And the R is relating to the X2s and Y2s. In other words, what I mean here is, look, anytime you have an R, it's the X2, so R is Y2. And the best way I can describe that is I actually use an engine. It's very simple engineering. It's a beam analysis, right? So I just, again, don't worry about the terminology. So if you had a beam, okay, change the color. So if you had a beam, and let's say that's supported at 2 points. This could be a house, right? This could be the first floor of a house, just done graphically. And it's called, so this is a beam. And if you had a person standing on it, or look, let's make it easier, it's a bridge, okay? So at a bridge, you have things called abutments holding up the bridge, okay? So this is a bridge, right? And you have a car on the bridge, let's say, and the car is, let's say, 20 tons, right? Now, let's say that car, the length of this bridge is 10 meters. So let's write that down, right? That's 10 meters. So that's 10 meters. Now, I just changed the color. This is just an aid for you to remember inside in the exam, okay? Now let's say that this car, well, it's 8 meters. We'll call this point A, right? Abutment A, we'll say, and this is abutment B. Now, the force there, so what we're going to look at is the force on this abutment. In other words, the loading on that abutment and the loading on this abutment. We'll just call that FA and FB. So in other words, if we apply a load, so we're applying the load of 20 kilonewtons, right, at a point, right? And I'll just do the color pink. Let's say that that load is 8 meters from point A. Sorry, it's a funny thing with this pen, I don't know what it is. So I'll just call that 8 meters. And then obviously this is 2 meters. Now, we can calculate the load on them, right? So if you can imagine, if you were, say, if there was 2 boys or 2 girls, doesn't matter, standing underneath, lifting up that beam, right? Who's going to feel the weight more? Well, just from looking at it intuitively, you'll say that it's the person under B is going to carry more of that load, right? So actually, this person is going to carry FB, which is 8 over 10, which is the total load, multiplied by 20 equals 16 kilonewtons, right? That's just kilonewtons, we'd say, right? That's just the force. And similarly, FA is he's going to carry 2 over 10 multiplied by 20. So he's going to carry 4 kilonewtons. Okay, does that make sense? So in other words, if you're looking there, right, so if you have a load, the person obviously underneath B is going to feel more of that weight, right? I know it's a bridge, but so in other words, you're saying more load is on B than is on A. So similarly, right? So what I'm trying to show here is when I did the R going to the opposite one, the S goes to the opposite one. So S goes to the further away point, right? So in this case here, the loading, I'll change color. Can I change it? That's great. So the loading, or the distance of 2, well, that relates to this one. And the distance of 8, well, that relates to this one. Now, again, you don't need to know this, but it's just inside the exam, just so that you get the right S with the X1 and the R with the X2. Just maybe think back to this beam. In other words, it's the one that's furthest away. So in other words, the person who's nearest the load is carrying more of the load, and to get that, they have the further distance, right? It's just a thing to maybe just to, when I was doing this, I thought that's the same as beam theory, really. So look, that's that. We'll do an example with the divisor's formula later, I think, as well, okay? Actually, maybe we'll do one quick example of that there now. Yeah, let's do it there, right? Sometimes it's better to do examples with real numbers. So just, okay, so let's say we have the points A and B, right? And the points A is equal to 3 minus 7, and the point B is equal to 2, 6. Right, so we want to find the the midpoint in that line, right? So we can say, we know the divisor's formula, we had it up there a while ago. Let's say C, so that's the point we're looking for, right? The midpoint. We called it D a while ago, I'll call it D again. D is equal to S times X1 plus R times X2 all over S plus R. I'm writing out the general equation or formula for the divisors, all over SY1 plus RY2 all over S plus R. Okay, but here we're asked for the midpoint, right? And the midpoint, S is equal to R, okay? So we can use the simplified version, right? So in that case, we say that D is equal to, so S is equal to R, so in this case is 1 and 1. So we had it a while ago there, X1 plus X2. So X1 is 3 plus 2. So it's 3 plus 2 all over 2. And it's, just double checking that I'm right, is minus 7 plus 6 all over 2. So that's equal to 5 over 2 and a half, minus a half. So in other words, if you have these 2 points, if you're given these 2 points, that's the midpoint between them, okay? That's just an example of that, right? Let's move on and do the last one, which is the distance formula. And then that's basically, then that's the whole course completed. So it's the 7 is the distance formula. Okay. So we have the y-axis, we have the x-axis, and again we draw a line. So we're given 2 points. A, we call this A, which is x1, y1, and B, which is x2, y2. Okay, so what we're asked here, right, is the distance. Let's call it, I don't know, we call it L, right? So we just want the length of that line, okay, given those 2 coordinates. All right, what I'll do here again is I just do I'll bring all the points down to the axes, right? So obviously we know that's x1, we know that's x2, that's y1, and then I drew this up in the wrong place, and that's y2 there, okay? Now, again, I'll just complete the triangle. Now, what we have there is a right angle triangle, isn't it? And we all know Pythagoras. Remember Pythagoras? Right? Let's talk about Pythagoras. We have this triangle, right angle triangle. And let's say we have A, B, and C. And what does Pythagoras say? Pythagoras says that C squared is equal to A squared plus B squared. Okay? Or I can say that C is equal to the square root of A squared plus B squared. Okay, that's Pythagoras. Now, let's apply Pythagoras to our case, right? So in our case, C is equal to AB, isn't it? We'll just call it, define it as AB. So that's AB is equal to the square root of A squared. Now in our case here, A, right, that's this length here. So what's that? That's x2 minus x1, isn't it? So again, people get confused with this, right? Say if that was 10, and say if this was 4. Well, what's that distance? It's 6, isn't it? So what's that equal to? 10 minus 4, so it's x2 minus x1. Again, that took me a while to get that right. So we say that's x2 minus x1 to be squared. That's A, right? So I just substitute that into that, so that's that, right? And now we do similarly for B. So B in this case, that's this height. and that's just y2 minus y1. So plus y2 minus y1 to be squared. And that's it. We've actually now gone through everything, right? Just on this, I've had to use this distance formula a few times. Don't know if anyone who's online here today is from Bandon, right, or knows Bandon, but there's a river flowing underneath Bandon. It's a tunnel. It's very long, and it's kind of dark, dirty, muddy. It's not very nice. And when we went out in 2001, it was the first time all the bridges of Ireland were inspected, and there was no inventory on the bridges. No one knew how long they were, what shape they were, what they were made of. So we had to find that information as well. And we had laser meters, which, you know, you just point it and you get the distance, right? But in this case, because the tunnel was kind of, it was dark, it was muddy, it wasn't a very nice place to be. There was a slight bend in it, so we couldn't get the length of the tunnel using our tapes or distomats. So we came up with a solution, and we used the distance formula. We actually did, right? So what we did is we had the GPSs on us, and we got the coordinates when we stood at one end of the bridge, and we recorded it, and we went down to the other end of the bridge, and we got the coordinates, and then using this exact formula, we got the length of the tunnel, right? So again, this is showing that maths can be used in the real world, right? And again, I just want to show you this distance formula on another job. So something similar, right? If I just go to Safari here, get rid of that. This is a job I did up in, it's the M17, M18 motorway, which goes from Gort, which is down here, to Tuam. It's the newest motorway in Ireland, I think. Yeah, pretty much. And in Tuam, at the very end here, I don't know if anyone knows Galway, but at the very end here, there is, if I can zoom right in, I can. You can just see it there, the outline, right? That's actually a pedestrian bridge. And hopefully this works now. So if I hop on this street view, I can go down here. No, I can't really do it here now. I'll try again. No, it's not working, right? I'll try one more time. Street view. It's not working, right? But anyway, this is a very complicated structure. Or maybe if I go closer. And I was given, effectively, that's the bridge. I was given coordinates of parts of the bridge, but I didn't have the coordinates of all of the bridge, right? So for example, each one of the piers is made up of an individual square. And I was given, let's say, the coordinates of each of the squares, the corners of each of the squares. But what I wanted was the center point. So I just devised an Excel spreadsheet. I mean, there's lots of piers. There's one here, one here. You can't see it now because I don't have a pointer. But there's lots of piers on this, right? And it's the way I did it, I divide up a spreadsheet, and I just used the distance formula and maybe a few other formulas that I had from coordinate geometry to get the exact center point of the piers. So again, that's another example of we actually do it in real life, right? And now when I went inside in the class in UCC, when we had every year, I got Yi to solve this for me, right? I just want to show you how coordinate geometry can be used, right? So for example, say we want to find the distance between Cork and Armagh, right? For example, let's zoom in to Cork and let's get a coordinate on Cork. This is just the EPA website. So there's a tool here, measurement tools. And if I just click on, say, somewhere in the center of Cork there, right? I get the coordinates, they're over here. And I write them down on a piece of paper for myself. So the coordinate for Cork there, if you can see on the screen, is the easting, right? That's 167,920. And that's the x coordinate, and the northing is the y coordinate, and well, that's 71873. Okay, that's the coordinate there for what is it? Patrick's Bridge, is it? Yeah. Okay. So now let's zoom out, and let's go up to anywhere at all. I usually pick Armagh. Let's pick Armagh. Let's zoom into Armagh, right into the center of it. Lonsdale Road is the name, so I just clear those measures, and I get the new coordinate there, right? So I just say get coordinates. And I just click on, let's say, the Astro Park there, okay? So now I have the coordinates for that part in Armagh, and that has the coordinates 287, which you can see on the screen, 287,882. And the y coordinate is 345,854. Now, if you bear with me, I'm going to plug that into the distance formula, right? Which is basically, as we just did a while ago, it's x2 minus x1 to be squared plus y2 minus y1 to be squared. But in this case, the x2 is at 287,882, so I'll just plug that into my calculator here, 287,882 287,882 minus the x coordinate for Cork, which was the easting, and that was 167,920. You get 119,962. I'll square that, and it's a number like 14 million, right? 14,390,881. Okay, plus let's do the y coordinate. So it's the y2 minus y1. So the y2 in this case is 345,854 minus the y coordinate for Cork, which was 71873. I have that, and I square that value, and I get a value of about 75 million, right? 75 million and 65,588. Now, I add the two of them, plus 14,390,881 equals, I put this on, there's no way to put this on the screen, but I'm just working it out, right? And then that's equals that, and then I square root of that equals, so I get a value of 274,007 meters. In other words, 274 kilometers, okay? Now, there's another, I can actually measure the distance here, right? Just to see if we're right. Just to show you an example of how actually coordinate geometry works, right? So I can measure the distance. Now, this won't be exact because I can't remember exactly where I was. But I was here, wasn't I? Top of Patrick Street, let's try. So from here, let's get to the distance. Oh, it's not going to work now, so, but it'll be, I'll just clear the measures because I have to zoom the full screen, clear all the measures there. So I measure the distance between Cork and Armagh. Not right. But I get a value there of 300, which isn't far off to 274 kilometers. But if I was more accurate, it would be right. So that's just an example of how coordinate geometry is used absolutely in the background here. This app, that's what it's doing, right? Now, obviously, if you went by road, it would be taking the coordinates of every single small little turn you take. So in other words, you divide the road between Cork and Armagh, which is, you know, somewhere all the way up there. It would be adding all the small distances you add, and then you'll get, obviously it'll be longer than 274 kilometers because this is as the crow flies. But that's just an example of how you would use, you know, coordinate geometry in the real world, right? Okay, I'll go back to the very final point here now. Is I'm just going to give you some tips for the exam, right? So I call this 8. I call it extras. And it's just a kind of a look at a small summary of some things I've seen in some of the questions in the past, right? So the first thing there, it's come up once or twice. It's called, let me just call it collinear lines, right? What does collinear mean? It means that the lines are on, that the points are on the same line, right? So collinear points. So if you have some line, let's call it, you know, you have 3 points on it, P, let's say Q, and we have R. So you're asked to prove that they're collinear, right? So there's a few ways to do it. I like the last one the best, right? So the first one, you could use the distance formula, and you could find out what PQ is. If PQ plus QR is equal to PR, well, that's proving that they're on the line, isn't it? So in other words, we're saying that this distance plus this distance equals that distance. Yeah? Okay. The second way of doing it is to prove that the slope of PQ is equal to the slope of QR. Okay? That's another way of doing it, isn't it? So if in other words that the slope of PQ is equal to the slope of QR, well then they're obviously on the same line, because if the slopes were different, then you'd have like PQ going this way and then that way, you know, something like that. But the last way I like is, I think is the nicest way. This is the third way. You could do, there's 3 ways of proving this, and this is the third one. You could prove that the triangle PQR is equal to 0. In other words, if you've had those 3 points and you transform the P, let's say, down to 0, 0, and use the area of a triangle formula, and you plugged in Q and R, well then the transformed Q and the transformed R, if the area of the triangle is 0, then obviously it's a line. In other words, that the apex of the triangle is down on the base, right? That's one thing. That's collinear lines. The second one I'll do is B, which is points on the same line, right? Or points on the same or opposite sides of the line. Okay. So let's say we have a line, right? Let's say the line is L, and we just define it as AX plus BY plus C equals 0, okay? And we have two known points. So the points would be X1, Y1, and X2, Y2. Okay, so they're the points, right? You're asked, are those points on the same side of the line? In other words, you have a line here like this, right? So that'll be your line L, right? And let's say there's a point here, X1, Y1, right? And this is your point over here, X2, Y2, right? Now I've shown them on opposite sides of the line here, but they don't have to be. So what we're asked here is to, like, are those points on the same side of the line or on the opposite side of the line? Well, actually, all that you do is you just plug in your values of x1, y1 into that. So in other words, you'd have a x1 plus by1 plus c, right? And then whatever that is equal to, whatever that is equal to. And then you do the same for the other one. You do a x2 plus by2 plus c. Right? Let's call, I don't know, let's call this y, it doesn't matter, right? I'm just calling this z. Maybe y is the wrong thing to use there. I use different letters. Let's call this, let's say the value you'll get is going to be r, and this ends up being t, right? Doesn't matter. They're just numbers. Now, if r and t have the same, so this is the solution, so 1. If r and t, for example, have the same sign, i.e. they're both positive or negative, right? So in other words, if r is equal to minus 20 and t is equal to minus 40, then they're on the same line, same side, right? Same side of the line. Second case, if they have different signs, sorry, let's do it. If they're both equal to 0, say if you pull in x1 into the first formula here, right? And then r is equal to 0, or t is equal to 0, then that means that the points here and this point, they're on the line. And the third possible solution is if they have different signs, i.e. one is positive, the other is negative, then they're opposite sides. Okay, is that clear? I think I usually get feedback and they say yes or no. But yeah, they're just two things I think could be very useful in an exam, right? So again, it's all about, you know, knowing that if you have a point, and say for example, and you plug it in and into this formula, the general equation, and it's equal to 0, then you know that point is on the line. For example, at the very start, if I put in, you know, remember the line y equals x? Well, if I put in the points 45, 45, I get 0, don't I? Because if I brought it across, it'd be y minus x equals 0. Then 45 minus 45 equals 0. Therefore, I know that that point is on the line. If I put in the point, say 4, 6 into that line, it would be 6 minus 4 equals 2. Therefore, that's not on the line. Okay? All right, what time we're looking time-wise? Okay, we have a few minutes. So what I plan to do now is just going through some, maybe some past papers. So we start off with 2019. So hopefully this works now. I can bring it in, 2019. And this one, so that's it. Let's squeeze that, move it over. I just have to go a bit lapsy, as we say. Let's make it a bit bigger. Okay, that's better. All right, let's change that to line grid. Okay, so that was the question in 2019. It says the line P makes an intercept on the x-axis at A0 and on the y-axis at 0b, where A and B are not equal to 0. Show that the equation of P can be written as x over A plus y over B equals 1. Again, that looks like an awful question, but like, right when I sat down the other night, I just said, okay, what do I know? Look at the equation, look at the question, what does it give you? So write down what it gives you, right? I mean, what do we know? Let's look at it, x over A. Yeah, remember the slope-intercept formula? Let's go for that, okay? So I'm going to get the slope of the line, P, right? So let's get the slope of the line. So that's m of P. The line is called P, right? So we have x2 and x1, y1, and we have x2, y2, right? So let's look at it. So that's what we say there is y2 minus y1. So y2 in this case is, we'd say it's 0, right? Because it's 0. Minus b all over a, which is x2 minus 0. So in this case, look, I write it down, like I'd say that this is x2, y2. Doesn't matter which one you use, actually. Just be careful with the signs. x1, y1, right? So in other words, we say the slope of the line is minus b over a. So now we have the slope of that line, right? But remember, the m is equal to y2 minus y1. Remember, I had a more general way of writing that was, remember I substituted the y2s and x2s with y and x, right? So generally then we're saying, and there's a few ways to answer this question, by the way, but this is just the way I did it. We had, remember, y minus y1 all over x minus x1 is equal to m. But m in our case is minus b over a. Now, it doesn't really matter which one you pick here, right? But I just picked, let's just fill in for a and b on this, right? So y, let's fill it in. So I'll write out slowly, make sure we're right. I abbreviated here. So it's y minus y1. And in this case, well, our y1 is b, so it's y minus b is equal to minus b over a. That's just slope times x minus x1, and x1 in this case is 0. So I just bring the a across there, right? So that becomes a into y minus b is equal to minus b x. The 0 is gone, right? So writing that out a bit nicer, we have ay plus b. I bring the bx across. Ay plus bx equals ab. Now, let's divide by a. Look, we're trying to get this, right? That's what we're trying to get. So let's divide across by a, so we get y plus b over a x is equal to b. Okay, now let's divide by b. So then we get, I'll write it out the way they have it, so do the chart as x. So I know I'll do it the proper way. So it's y over b plus divide by b, so the b on top goes away, so that's x over a is equal to 1. So rewriting that, we just get that it's x over a plus y over b equals 1. That's the answer. That's what they asked for, okay? That was that question. The second part is here. It says the line L has a slope m and contains the point A 60. Write the equation of the line in terms of L and M. Again, it looks a bit strange, right? But again, just write down what you want, right? So let's say slope m is equal to, we just call it, sorry, I'll just define that now, right? Say slope m. Shall I start again? Okay. So we're told the slope m, we're given, right? Let's write down what we have. So we're given slope equals m, and we're given the point A, which is 6, 0. That's all we're given, right? And we're asked to write the equation of the line in terms of the line L in terms of m. So again, let's go back to the general equation, y minus y1 all over x minus x1 equals m. So in this case, it's y minus 0, so y1 is 0, all over x minus 6 equals m. So working that out, we get y is equal to m into x minus 6. And just to finish it, then we say that y is equal to mx minus 6m. That's the answer. That's the answer to that one. Okay, that was 2019. I would say like that was fairly straightforward if you knew it, if you knew where to go, if you knew your slope of the line, if you knew which formula to use. Could you have done that by, you know, battering through past questions? If you're lucky, you would have come across something similar. But again, just understanding the most fundamental thing in the, and that's why I went very slowly at the start this morning, is the slope of the line and the equations of the line. If you spend most of your time just understanding them, the rest will fall into place. The rest is just learning off formulas. But that, if you understand the slope of the line and the equations of the line, really understand them, understand that you can manipulate them, understand that the three ways of writing the equation, well, it's just the same equation, just written in a different format. If you understand that, you'll go a long way in the exams, you know. Let's go on to the next one there now, which is, oh sorry, there's a part 3 on that actually, you know. If I can find it. Cuts that axis, I think that's it there. No, it's not that one. Bear with me there now a second. Just tell me I need to just bin that. It's kind of hard to see what I'm looking for here. 4x plus 3y, oh yeah, this is it I think. Yeah, that's it. So that was part 3 of that question. So let's give that a go. It says the line, can you read that? You can say, yeah. The line L cuts the line K, 4x plus 3y equals 25 at P. Find the coordinates of P in terms of M. Give each coordinate as a fraction in the simplest form. Now this was a horrible question because it's, you can make a lot of mistakes. So again, let's write down what we have first of all. So K is the first line, right? And that's 4x plus 3y equals 25. And the second line, L, what is it? Well, L was from the previous question, isn't it? Yeah, so it's from the previous question, yeah. So we had that from the previous one, and that was y is equal to mx minus 6m, so I'll just write that in a different way. So it's minus mx in the previous part plus y equals minus 6m. So where I got that from there, look, is just, hold on. It doesn't allow me to go back now when I that up. Oh yeah. Right, we forget that, we're going all over the place. Down there, I have to squeeze out of that. Find where I am. No, not now. Yeah, there we are. So I don't know why it just jumped a load of pages there, right? But I'll just go back to it. There's L there, right? L, y is equal to mx minus 6m, okay? So that's where we got that from. So let's go forward there again. Right, so we have our two lines now, okay? And it says the line L cuts the line K at P. Find the coordinates of P in terms of M. All right, so we have two lines and we have to find out where they meet. Remember that? The very first thing I did this morning, remember, was simultaneous equations. So let's look at them. So I'll take, let's do the, I'll do that with you. So we take the line L and we multiply that by 3. And then we get 3mx. Is that right? 3mx minus 3y. Let me see if I'm right here now. So I multiply by minus 3, not by 3. So multiply by minus 3, and you get 3mx minus 3y equals 18m. And if I take the line k then, right, I'll just rewrite it again. You know why I multiply by minus 3? Because I want to get rid of the y values. So that becomes 4x plus 3y equals 25. Mind that. And then we get that 3m plus 4 x equals, do you cancel? 25 plus 18m. And then from that we get that x is equal to 25 plus 18m all over 4 plus 3m. We have one coordinate, we have the x coordinate. Now, if we plug that back in, I'm just conscious of time there now. I want to do more questions. So, yeah, we're okay. So if we plug that back in and we get y is equal to minus 6m. So I'm just plugging it back into this equation here. Y is equal to minus 6m plus m into, I'm just filling in for the x value, right? So that's 25 plus 18 m all over 4 plus 3m. And I won't work all that out right, but it comes all the way down to y is equal to m all over 4 plus 3m. So the answer then, right, the coordinates for P are the x value, which is 25 plus 18 m all over 4 plus 3m. And the y coordinate is m over 4 plus 3m. Okay, that's the answer to that. So that was last year, that was 2019. Let's go and look at 2018. So I'll just get that question in. Question 5. Oh, yeah. Okay, bigger. Okay. So part A, that question says the line m 2x plus 3y plus 1 equals 0 is parallel to the line n 2x plus 3y minus 51 equals 0. Verify that A minus 2, 1 is on m. The first part was incredibly easy, right? So let's write down A. But again, it's just no harm for you to, I'll just cancel that. Pick. So A is, so the point A is minus 2, 1. And you must prove that that's on M. So all you simply do here is you just plug the value minus 2, 1 into that equation, right? So the equation is 2, I read out properly out, 2x plus 3y plus 1 equals 0. Okay, so we must prove that the left-hand side is equal to 0. That's all we need to do here. So we just fill in the values. So minus 2, that becomes 2 times minus 2 plus 3 times 1 plus 1. Right? What does that equal to? Minus 4 plus 3 plus 1 equals 0. Here we see it's on M. Okay, that's part A. Part B is a little bit more complicated, but not that much. Okay, so let's start it down here, B. So question B says, find the coordinates of the point B, right? The point on the line N closest to A, as shown below. But remember before I told you that, and it kind of gives you a hint anyway, it shows you that that's it's the perpendicular distance, right? So let's write down again what we have. We have A, we know that the coordinate of A is minus 2, 1. Remember the perpendicular distance for a line formula, we have a line and we have the equation of a line and we have a point, but we don't have the equation of N yet, right? So there's a few ways to do this equation. So let's write down the general equation. Let's say N is equal to AX. Which way am I doing this now first? Find the coordinates of B, right? So the general equation of a line, I'll just do that for a second. So the general equation is AX plus BY plus C equals 0. And we know that the slope of the line AB, right, is, hold on, I just got to get this right in my own head first. Yes, we know that the slope of M, right, just from looking at the formula 2x plus 3y plus 1 equals 0. We know the slope of that, right? Remember at the very start, we knew that the slope of that is a minus 2 over 3, right? Which is minus A over B. Is that correct? Am I right in saying that? Yes, I am. I'll just go back to my notes to make sure I'm not making anything. Yeah, M is equal to minus A over B, and in this case, A is 2 and B is 3, so that's correct. So the slope of M, so now we're building up knowledge. Now we know the slope of this line. we know the other line is parallel to it, isn't it? We were told that. So we know that the slope of m of n is equal to the same, right? So we have the slope of the line, and we have the point on this line, but that's not really what we're interested in, right? Do you remember at the very, also, let's build this up now. We're looking for the slope of this line S. I'm going to call this line S, right? So the slope of this line S is perpendicular to the slope MM. So that means that, you know, the slope of S multiplied by the slope of M is equal to -1. So in other words, we're going to say that the slope of S is equal to 2 over 3. Because if you multiply 2 over 3 by -2 over 3, you get -1. Okay? Now let's go back to the general equation of the line. So we have y minus y1 is equal to m. That's not the general, that's the second format we wrote down. So we say that the equation for the line S, so we're actually working out what the line S is equal to, is y minus y1, because we know that the point A is on that line S. So we say y minus 1 is equal to 3 over 2 times x minus -2, which is +2. Because they're the points we're using, -2 and 1, right? So that's the point S. So let's work that out. You get 2y minus 2 is equal to 3x plus 6. So we find out then that the equation for the line S is equal to 3x minus 2y plus 8. So we were given the line M and we were given the equation of the line N. What we didn't have was the line S. Now we have the line S, right? Equals 0. So again, by simultaneous equations, we're going to see where the line S, which is this line, intercepts the line N, which is this line. That's the point, right? That's what we're looking for. That's what the S is for. Isn't that the coordinates of B? Yeah. So we have the line of S. That's the equation of S, and we have the equation for N, which we're going to just write out here. It's already there. It's given. It's the line in there, right? So N is 2x plus 3y. 3y minus 51 equals 0. And I just write out the line S above it there, right? It's 3x minus 2y plus 8 equals 0. Now, if I multiply this one by 3 and the second one by 2, so I'll do it 3 times S, and that becomes 9x minus 6y plus 24 equals 0. Be very careful when you're multiplying all these, because I was multiplying the other night and I put in the wrong value for 24. I put in 12 or something like that, right? And I got the wrong answer. Just be careful. And 2 times n, we'll say. That becomes 4x plus 6y minus 102 equals 0. So they cancel. So we're left with 13x is equal to 78. Therefore, x is equal to 6, and substituting back in, you get y is equal to 13. So the coordinates of B there are 6, 13. Okay, that was 2018. Okay, let's do the next one, right? The next one is actually quite a tricky one.
Yeah. Sorry, Mark, can I just interrupt you there? Okay. Sorry to interrupt. I've got a question in from a student, and it's, how is MS, the slope of S, 2 over 3? Why is it not minus 3 over 2, since it is perpendicular?
Oh, yes, you're right, Lee. He's right. M of S is actually 3 over 2. And I wrote it in later correctly there, right? It's actually, so what I do here, look, that's wrong. That's equal to 3 over 2. And let's show exactly why that is the case. So we say that M of N, which is minus 2 over 3, right? Multiplied by the M of S is equal to minus 1. So bringing that across, that becomes M of S is equal to minus 1 multiplied by that. So it's minus by minus, it's 3 over 2. Thanks, Eamon. Yeah, good to get that checked. Okay, but we carried on. We put in the right figure later on, but it was just, yeah, I wrote it down wrong there.
Sorry, Mark, just sorry to interrupt you there.
All
Another
right,
question
fine.
came in just as you were answering that. It was, where did the minus 51 come from?
We're given it. That's a given value. It's 2x plus 3y minus 51 equals 0. We're given the equations for line n, and we were given the equation for line n. We actually didn't need it. You could have worked it out. Oh, no, you couldn't. No, it was necessary. So it was a given value, Eamon.
That's brilliant. Thanks, Mark.
Okay. The next one is, I think, a very nasty question. But we'll have a look at it. Maybe it's no harm. So I'll just put that up there. Whoops. Okay. So what it says is, maybe we can make it a bit bigger. Okay. What it says is, let the triangle let ABC be a triangle. Prove that if a line L is parallel to BC and cuts AB in the ratio of S is to T, where ST are natural numbers, is it? Then it also cuts AC in the same ratio. This is a kind of a nasty question, right? I think, but it's all about drawing it out, and it's all about interpreting, putting the text into a drawing, right? So first of all, let's get ABC. So let's draw the triangle ABC. Okay. I draw it a different way there now. Let's draw the last bit. No. I'll try again. Okay, that's better. So I say we have A, B, and C. That's the triangle ABC. That's the first thing it says. Prove that if line L is parallel to BC. So let's draw in the line L that's parallel to BC. So that's more or less parallel there, I'd say. More or less, okay, we get the idea. And cuts, say, prove that if a line L is parallel to BC and cuts AB in the ratio S is to T. So AB in the ratio S is to T. S and T, right? Says prove that if it, the ratio S to T, the S to T, then it also cuts AC in the same ratio. So it says that, like, this ratio is the same as this ratio, okay? So the way I did it, I think it's a really nasty question, but anyway, I just wrote down what I had. We said that M of L, so this is the line L, we'll just write that down. This is the line L. Write down what you know usually, and then that's what I did. And I said, okay, that's what I have. Now I can try and prove it. We can say that the slope of L is equal to the slope of BC, can't we? That's fine. And then it's all about S to T. You start thinking about the divisor's formula. So I wrote out the divisor's formula. What I did is I call this the line P, the point P, and I call this the line Q. Okay, and then I call B here X1, Y1, I think. And let's call point A there X2, Y2. Okay, and just complete it, we say X3, Y3. All right. So we can say, using the divisor's formula, that the coordinates for P are the following. They're S times X1, yes, I'm just double checking that, S times X1 plus T times X2 all over S plus T, and then it's SY1 plus TY2 all over S plus T. Okay, and then I'm saying, I said, let's look at what else can we write down? Q. So I'm actually doing it kind of backwards. I'm saying that it does divide this up into S and T, and then we have to prove that they're the same, So then Q is S of X1. I'll just get size S of X2, not S of X. Let me see, I want to make it S of X3, yeah. S of X3 plus T X2 all over S plus T And the y coordinate is s times y3 plus t of y3, sorry, t of y2 all over s plus t. So that was just kind of setting up. Then I had the p and the q, right? And then what else did I know? They were saying that the slope, the PQ, obviously, right, which is the line L. So I'm saying that maybe I'll start over here. I'm just writing down what I have, you see. So I know that the M of PQ, which is the slope of this line, the red line, right, is equal to the slope of MBC, which is the slope of this line. That's basically what the question says at the start, to say that the red line here is parallel to the base, right? So in general terms, I can write that down as y3 minus y1 all over x3 minus x1. Yeah, that makes sense, doesn't it? Now, what I did then is I filled in that value, right? So I'm saying, let's get the slope of MPQ. Like we have the y3, we have the y1, right? These are these coordinates P and Q. So what I did is, I might go on to a new page here, or I'll try and write it down here in small writing. So M of PQ is equal to, I have to see what I did here now. S is y2 minus y3 minus y1. 3. So it's a new one. So it'll take me a little bit of time here to work out if you don't mind, but we will get it. So I'm saying it's the slope of BC, right? MPQ is equal to that. So let me see, but what I'm trying to get is the slope of this line, which is the Q and the P. So I have my coordinates of P. So if I fill that in there, which will be y2. So this is my new y2, if it makes sense. And this is my y1. This is my x1. And this is my x2. So this is a horrible equation, but let's try it. Let's see what happens. S plus t is over both of them, isn't it? So then it's y2 minus y1. So the y2 is s y3 plus ty2 minus y2 minus y1, which is sy1. And sorry about that. sy1. And then it's minus again. It's ty2. And then that's all over the same thing again, right? So I'll do x2 minus x1. So my x2 in this case is, and it's all over s plus t, right? Because you can see that it's the common denominator. S plus t. So x2 in this case is sx3 plus tx2 minus x1, which in this case is sx1 minus tx2. Now, oh yeah, I have more space here, good. So I'll just write this down here. So I'm going to carry on over here, okay? You can see that the s plus t, that cancels out in both, right? And you can see that ty2 here and ty2 cancel out, and tx2 here and tx2 cancel out, and then you're left with sy3 minus sy1 all over sx3 minus sx1. Now, what's that? Let's get rid of the s's. They all cancel out, don't they? So you're left with y3 minus y1 all over x3 minus x1. Whoops. Sorry. Yeah, it's on the place there, but that's actually x1 there, right? Stop. I'll write it out again. So what I've just proved there, right, is that I wanted to prove, this is what I wanted to prove. I wanted to prove that MPQ is equal to MBC. We knew that MBC is equal to this, right? I went away then over here and I calculated MPQ, and in the end, I got the same. Horrible question, isn't it? A lot of S's and Y's and T's, but it just proves that they're the same. So again, by saying that, we can say that they're cut in the same ratio. That was a particularly nasty question, right? But we'll move on. We'll do one more, I think, and maybe or two more. We'll see how we're doing time-wise. Okay. Right. Let me see, 2016. What I might do there, the last one, right, is it's 2014, is it? Let me see. Okay. So let's do 2014. Is this one. Okay. Let's make it a bit bigger actually. Read it. Okay, so it says the points 6, -2, 5, 3, and -3, 4 are shown in the diagram, right? Find the equation of the line through B, which is perpendicular to AC. So what are they asking for there? So let's read it again. Find the equation of the line through the point B, which is through this point, which is perpendicular to AC. So I'll try and draw it the best I can there. That's that line, okay? That's perpendicular to that. Right, that's all we're given. And then we're asked, find the equation of the line through B, which is perpendicular to AC. So we're looking for this line, so we'll call it L1. So let's write down what we have, right? We know if it's perpendicular to AC, we have the coordinates of AC. So let's write down the slope of AC. So I change writing there. So M of AC, I shall do it in capital letters. M of AC is equal to y2 minus y1 over x2 minus x1, which in this case is y2 is 4 minus 2 all over x2, which is -3 minus 6. So in this case, the slope is -2 over 3. Therefore, we know now the slope of L1, right? So we're saying that, that's perpendicular to AC. So we'll say the slope of L, as I call it, is equal to 3 over 2. Okay, which is the inverted, multiply those two together, you get -1. So then we write down the general form of the equation. We have y minus y1 equals, sorry, I'll just do that. Y minus y1 is equal to m into x minus x1. Because for the line L, the red line there, we now have the slope and we have a point on the line, which is the point B. So we say that L, the equation of L is equal to, we bring the 2 across there, right? So I'll do it out slowly. Y minus the y1 is 3 is equal to the slope, which is 3 over 2 into x minus, and look at the point B, so that's 5. And then working all that out, you get that it's 2y, and bring the 2 across, you get 2y minus 6 is equal to 3x minus 15. So the equation of the line, so we say L, the equation of that line is 3x minus 2y minus 9 equals 0. Okay, that's the first part. So the second part then says, use your answer to part A above to find the coordinates of the orthocenter of the triangle ABC. What's the orthocenter? The orthocenter is where the perpendiculars meet? I don't know again. I'm just trying to figure this out. I'll try and draw it anyway, first of all. So you put that line here. I think if you continue this line up here. It's a long time since I did this question, so I apologize for that. I think the orthocenter then is a line like that. A line like this. I'll draw it first and then I'll try and explain it afterwards. So we continue that line up there. Let me see what it is now. Anyone on the thing there know what the definition of an orthocenter is? Please chat it or tell Eamon what it is, right? And I'll work it out then, right? I think it's the perpendicular. Oh yes, I know what it is now. So it's the perpendicular it's perpendicular distance from here, A, isn't it? So that's, let's look what we did here with B. We got the perpendicular from the opposite through that point. So let's do the opposite here. So the opposite here would be, if you continue that line BC here, and then we got the perpendicular from A, we draw a line that way, and we do similar for this one. We get this line here, and this is the perpendicular, right? So in other words, we extend AB, right? This again was a tricky question, and again we extend BC. But what I was doing is saying, use what you did in part one, so do that for the other points as well, and you get that center, okay? So what I might do there is, I don't know if I can do this right. Can I copy that? What I might do actually, look, is I'll erase what I did there for part A. If I can do that. So if I erase, let me see, clearing. Right, that worked. So now let's do part B. And I'll redraw it there again, okay? So what we did for the first part was, we had the line here, and it was perpendicular to this point, and it went something like that. Okay, so let's do the same for the other points, right? So let's pick A, and let's get the let's say A, and the opposite is B. Sorry, the opposite is CB, right? So we want to do a line through A that's perpendicular to BC. So it's something like, I draw it in a different color. It's something like this. Okay, and we do the same for point C. So we just extend this out here. So getting through C, and it's perpendicular to BA, so it's going to be something like this. And look, basically, I can't draw here because it's too funny, but they all meet at a point, right? So we need to find that point, and let's call that point 0. Okay, so again, using what we learned in the last question, let's do the same thing. So we know the M of AB, we can work it out. It's the exact same, right? So that's equal to AB, the line AB, which is this line, which is the y2 minus y1 is 3 plus 2 all over 5 minus 6, right? And that's equal to minus 5. I'm conscious of time here now, so I'll fly through this if you don't mind. So perpendicular to MAB, right? AB is equal to 1/5. Okay, so then we'll call that, we'll call this L1. So we're going to call this one L2. Aren't we? Let me see now. Yeah, this is L2, right? So we say that for L2, using similar to what we did in part 1, L2 is equal to y minus y1, which in the case what we have here is point C, so it's minus 4, is equal to 1 over 5 times x plus 3. Now working down through that, we get that L2 is equal to x minus 5y plus 23 equals 0. Okay, and then we have L1 and we have L2, right? So I'll rewrite L1. L1 from the first part is 3x minus 2y minus 9 equals 0. So again, we have what we have here now is the line L1, which I've drawn there in red, and L2, which is in blue. And what we want to find is where they meet. So again, we use simultaneous equations between these two. I won't do it out because I'm conscious of time, and but you'll find out in the end that the coordinates of O are the points 7 and 6. So again, you'd be multiplying 1 there by, I don't know, fill in the values. So do simultaneous equations. Okay, so that's it. I'm finished for, let me see, I'll just go back to something. We've gone through everything. We've done the slope of the line, the equation of a line, the area of a triangle, the perpendicular distance formula, the angle between two lines formula, the divisors formula, and the distance formula. We've covered everything. As I say, if I was spend most time on slope of a line and equation of the line, because the rest are just formulas, but if you can really understand the slope of the line and the equation of the line, and what's really important is setting up diagrams, being able to draw a line. So if you're given any line ax plus by plus c equals 0, what I always do, fill in for x equals 0, fill in for y equals 0. Straight away you have 2 points, your 2 coordinates on that line. Draw that line. Inside in an exam, just draw it. It'll, like I was in the last question there with the orthocenter, I still don't know what an orthocenter is, but I just looked at what we did in part A, and I knew that what they're saying is do the same again. So I picked, instead of picking coordinate B this time, I picked coordinate A, and I applied the exact same rationale, the exact same method, and then I knew what we had. Then we had the two lines, and then it was where they meet. So even though I got stuck there, I worked my way through it because I knew the basics. I knew the slope of the line. I knew how to use the slope of the line equation, the slope-intercept equation, and basically manipulating slopes and perpendicular slopes. So guys, that's it. I think I'm back again about 2 or 3 weeks time with integration, probably a bit more challenging. I hope you learned something today, and particularly there with the little extras I gave you, but I just think that this is a little topic that you could score highly on. Yes, maybe some of the other topics like whatever, you do need to do a lot of past papers. But with this, yeah, do the past papers. But I'd spend more time really understanding parts 1 and part 2 there, and it'd go a long way to making the exam easier for you. Thanks a lot. Cheers. Bye.
Thank you, Mark, for a great presentation there. And definitely for the students, go back through the examples and make sure you understand what's going on, because understanding is critical to being able to answer random questions that they throw up at you like that. Again, as last week, in the tables, the formula and tables booklet, in pages 17 to 19 this time, there are lots of equations that you can use, so you don't need to remember them. But you do need to know how to use them. You do need to know what they actually mean and how to apply them. So, as Mark said, make sure you understand what you're doing, and then it falls into place with a little bit of practice. Also, have a look at the khanacademy.org. There's a lot of nice examples in there also. So once again, thank you to Mark, and hopefully we'll see you all here again next week for the geometry of the circle tutorial. Okay, so bye for now.
Bye.